When talking about the data analysis, many people would think of BI software. BI literally stands for business intelligence, which is just for data analysis. Moreover, BI software typically features smooth interactivity, attractive interfaces and user-friendly functionalities. That seems very appropriate. However, BI has technically been heavily narrowed to multi-dimensional analysis. That is, to summarize a pre-built data cube according to the specified dimension, and present as tables or charts, supplemented by drilling, pivot, slicing, and other operations to change the levels and summary ranges. Indeed, it can help find valuable insights, such as identifying specific time periods and departments responsible for high enterprise costs, when the total cost is too high. But, the data analysis tasks are not always so simple. For example, stock analysts speculate that stocks that meet certain conditions are more likely to rise. Sales director to consider which type of sales staff would be more effective in handling difficult customers. Data analysts at e-commerce companies determine that rewarding users with certain characteristics at a lower cost can yield higher than average revenue. These tasks involve multi-step interactive calculations, which go beyond simple multi-dimensional analysis. Then, what kind of data analysis procedures can address these tasks? For example, when searching for stocks with potential for growth, analysts might make bold guesses based on their experience. They may believe that stocks meeting certain criteria are more likely to rise in the future. Then, they analyze historical data to identify stocks that meet the preset conditions. Next, they examine the trends of these stocks to see how many actually rise as guessed, thereby verifying their guesses. If the guess is wrong, they can adjust their guess, change the conditions, and continue to verify the guess with historical data. If the guess is correct, a reliable conclusion can be drawn that will guide future stock trading. This completely resolves a data analysis task. The essence is to repeatedly guess and verify based on historical data, and ultimately identify a consistent pattern. Experienced business people will make guesses, and what remains is to help them verify these guesses, which means doing calculations on historical data. The characteristic of this type of calculation is that the process cannot be designed in advance. The analyst will decide the next action based on the results of the previous step, essentially conducting the calculation process freely. This is interactive calculation. It's similar to using a calculator. Unlike ordinary numerical calculators, data analysis requires calculating not just simple numbers, but a batch of tables, which is the structured data. This capability can be aptly described as a tabular data calculator. Excel is a tabular data calculator. For example, add a calculated column. Then sort. These are all interactive calculations. Even, the multidimensional analysis function of BI is in the Excel pivot table, though with a less attractive interface and smoother operation. Excel is the most commonly used data analysis software for business people. After using Excel for data analysis for a long time, troubles have arisen, and many tasks are difficult to implement using Excel. Excel has capacity limits, and as the data volume increase, it cannot run smoothly. When dealing with a few 100,000 rows, it may become noticeably slow, and with over 1 million rows, Excel directly becomes unable to operate. Excel is not good at set operations and operations after grouping. For example, in the case of the stocks that are more likely to rise mentioned earlier, one step in the verification might be to find periods of stock price increases lasting more than 5 days to see if there is a pattern. This task involves ordered groups, and keeping grouped subsets for filtering, which are difficult for Excel. How about using a database? Databases can handle slightly larger data volumes without issue, but the setup can be complex. Excel, on the other hand, requires tedious data importation before analysis. Moreover, SQL is often much more difficult than Excel. For example, to calculate the longest consecutive rising days for each stock, the following nested SQL code can be a significant challenge even for professional programmers. But Excel makes it actually simpler. First, sort by code and date. Second, use a formula to calculate the number of consecutive rising days. Third, group and summarize to find the longest consecutive rising days. Fourth, collapse result for display. This intuitive four-step process is much simpler than SQL. BI can't be relied upon either. BI themselves are not difficult to use, but they still rely on databases to handle big data, and face similar challenges with setup. Moreover, as mentioned before, as BI has been narrowed down to multidimensional analysis, its computational capabilities are even more inferior to SQL. It couldn't even handle the task of consecutive rising days of stock mentioned earlier, which could be quite limiting for an Excel expert. Then it seems learning programming is the way to go, as there's nothing that programming can't solve. For example, Excel's built-in VBA is readily available, and comes from a reputable vendor. It seems promising. However, VBA is overly simplistic and struggles with handling tabular data, making everything tedious. Moreover, it doesn't provide direct support for big data, so everything needs to hard code. What about Python, which is widely endorsed by training courses everywhere? Python's table calculation ability is decent, but it is still a bit complex to write. For example, calculating the longest consecutive rising days for each stock has to be written like this, and there is also an explicit loop. In addition, Python also lacks direct support for big data and requires hard coding, which is far beyond the capabilities of Excel players. Moreover, the interactivity of programming languages is not as good and is far from being as user-friendly as what you see is what you get Excel. This doesn't work, and neither does that. Are there any other options? Here is esProc Desktop, a post-Excel data analysis tool. esProc Desktop provides a powerful programming language SPL, with rich table processing capabilities, concise code, and strong interactivity, making it an ideal tool for data analysts. SPL code is written in a grid similar to Excel, and programming is akin to writing Excel formulas, making it suitable for analysts familiar with Excel. Cell names are natural variable names, which intuitively reference previous calculation results, and are very familiar to Excel users. View the results of each step at any time on the right panel, automatically displayed in a tabular format. Grid indentation can also effectively indicate code scope, making it very intuitive. Take the stock rising periods task mentioned earlier as an example. It can be divided into 5 steps: reading files, sorting, ordered grouping, filtering, and merging. After gaining proficiency, you can accomplish this with just one statement. SPL provides powerful table operation capabilities, much simpler than Python. For example, calculating the longest consecutive rising days for each stock can be done in just 3 simple lines. To find the periods during which the stock has risen consecutively for more than 5 days, and it can be implemented in 4 lines. Not only does it have the simplicity of Excel, but it also handles complex tasks that Excel struggles with, truly achieving a both-and solution. A more complex task: find the number of active users for 3 consecutive days in every 7 days. Python and SQL code is obviously too long and complex. It is almost impossible for business personals to master. SPL code is much shorter and easier to understand. Ordinary business people can master easily. SPL also has natural big data processing capabilities. It can handle external storage calculations exceeding memory easily. It also supports parallel computing, utilizing multiple CPUs for faster performance. esProc Desktop also provides an Excel XLL plugin, allowing users to directly write SPL code in Excel while leveraging the advantages of both SPL and Excel. Calculating consecutive rise periods can be done with just one line of formula in Excel. Isn't that convenient? Another example: finding the star products that make it to the top 10 every month. The intersection in Excel is troublesome. SPL's set operations are much more powerful, and a short formula gets it done directly. esProc Desktop is freely available, and comes with abundant resources including books, courses, and Excel routines. Excel data analysts, download and try it now to boost your skills.